Over the past 6 months, I've been building and training this open-source robotic arm using Hugging Face's LeRobot framework. Instead of manually programming every movement, the goal was to teach it through demonstration using imitation learning. Here's how the project came together, the challenges along the way, and the results. Okay, it is 11:30 at night right now. This took forever to troubleshoot, but it finally works. But right now it's just being set to fully cooperate. Look at this. I'm gonna hold this like that. Isn't that awesome? Like look at that. I mean, it's not perfect. There is still a gap over here, and this isn't right because this is 90 degrees off. But I'm gonna try to pick up something. Okay. Okay. Uh-oh. Okay. Yes. Oh my god, look at this. Okay, so I will fix that. I'm just gonna recalibrate it in the morning. Yeah. I'm so tired. I'm gonna go to sleep. Okay. What if instead of programming every possibility in a changing environment, you can simply demonstrate a task and the machine learns to do it? Imitation learning is a machine learning technique where a robot learns a task by observing demonstrations instead of being explicitly programmed. Traditionally, if you wanted a robot to pick up an object, you would write an algorithm that determined where the object is, calculate the motion path, control each motor, and handle different situations. With imitation learning, instead of writing instructions, you can just perform the task yourself. The robot records everything it observes during the demonstration and trains a neural network to do the same thing. After I built the robot, I recorded a few episodes and trained the robot using the ACT policy. The episodes recorded contain data such as the camera feed, joint positions, and timestamps. The collected demonstrations are then used to train a neural network. The network repeatedly uses observations from the dataset and predicts what action should be taken next. The prediction is then compared to what the human actually did. The difference between the prediction and the demonstration is the training loss. The neural network gradually improves until its predictive actions match the demonstrated actions. Okay, so this is the first test of the training model. Yeah, it's not doing super well. I can see that it has the intentions to pick up the block. Yeah, it's not great though. So it has a clear intent to move the block into the dish. It just kind of misses the mark just a little bit. If I give it a little bit of help. Yep, no. It might have an error just because I didn't clear. Oh, I guess it works. Okay. So. Okay. Oh. Ooh. Whoa, wait, oh my god. Come on. Oh my god. Oh my god. It just failed at the, oh my god. It did it for like 20 seconds. Did you? I'm gonna reset this. Okay. Okay, this might work a bit better. No. Yeah. Oh my god. Not quite. Oh. Okay, around an hour ago, I finished training. So I started with recording 25 episodes. I only did 25 episodes just with random position of the cube into a non-moving box. And then I let it train for an hour with 20,000 steps. It might be too much, so that's why I'm trying different things. And I'm using this command to let it try it. So I wasn't able to use my previously trained one because something happened and everything broke. It kept having an error with, so the lower the number I found, like I found that the lower the number of steps, this is the step count, the lower the number, the more jittery the robotic arm is. But the higher the number, the more smooth it is, but it keeps trying to go into a phantom position where it learns too much from the 25 episodes that are recorded and it thinks it's somewhere else. It just kind of copies what it is trained on instead of actually trying to go. Take a moment. All right. Okay, so it understand. Oh my god. Okay, I just wanted to show this because this is, oh my god, kind of funny. Oh. Okay. Ooh. Whoa. Yeah, it tried, but didn't really succeed. Oh, I think it's because it's looking too much into the future? Maybe? Okay, it's saying it again. It might just be spending, I think the pauses are actually being caused by me setting the steps too long, but this is having the same issue with ACT, ACT policy. I don't know why I say ACT, so. Okay, it is done training. Let's give it a test. I trained up to 9,000, so I'm gonna start with 9,000. So this one. Yeah, just here. All right. Hopefully, no. That's on 5. Wait, what? No, 5,500. Oh, oh, I'm gonna random position. 6,500. So. Okay. Whoa. Whoa. Immediate grab. Holy moly. Here? That was extremely close. Okay, okay. Oh my god. That is so amazing. This is a bit far. No way. Oh, wow. Okay, okay, that's awesome, man. Maybe there's not much training danger there. Sorry, there's not much training data there. Yeah. So it seems like, wow, this works pretty well. I mean, definitely I think more training would make it better. Well, not more training, more episodes of recording. So for the next step, I feel like I'm going to add on to the recording instead of training from the beginning, because it's pretty good at this point. And after that, after I get a reliable model, after I document everything and make sure I know what I'm doing, I'm going to make a new enclosure for this. So I'm gonna attach this to a piece of wood, maybe have the box not be here because it moves around a lot, and maybe like over here, I've seen in some places they put the box like over here attached to this base so it doesn't move. And I'm gonna construct a more stable environment. There are gonna be a few issues though, power being one and computer being another. That one might need to be on the floor instead of being attached to a table. So yeah, but I feel like there's a lot of places to improve on. In this video, I showed how I used imitation learning to teach a robot how to pick up a cube and put it into a dish. This is a pretty simple task, and I picked it for demonstrative and learning purposes, and I'll be doing some more advanced and cooler stuff with this robot in the future. Now, you might be wondering how this, or imitation learning, is useful. Many real-world tasks are surprisingly difficult to program. For example, imagine making a program for a single robotic arm to fold the laundry. This is difficult because fabric is unpredictable. Clothes do not have a rigid structure, and the fabric bends and wrinkles. With imitation learning, you can instead demonstrate folding a towel, a few hundred times. The robot learns the relationship between what it sees and what action should follow. A real-world example of imitation learning is Tesla Autopilot, where neural networks are trained on millions of hours of videos and driving data collected from human drivers. Thank you so much for watching. The possibilities for imitation learning are endless, and I'm excited to see what I can do with this project in the future. See ya!